is Brian Albright, Editorial Director at Digital Engineering Magazine. Welcome to the DE 24/7 podcast. On today's episode, in anticipation of the CAASE21 conference happening here online on June 16th, we'll be speaking to Professor Steve Kahn and Professor Deminda Wijesekera of George Mason University. They'll be delivering the keynote session at CAASE21 this year, titled Challenges of Fully Integrating Sensor, Vehicle, ADS, and 5G Technologies to Achieve Reliable and Safe Transportation Systems. We spoke to them about some of the simulation challenges involved in autonomous driving and connected cars, as well as how some of the simulation tools in the industry are changing and evolving to meet those needs. I just wanted to get kind of an overview of the session. And I know, based on the description, there's this influx of new technologies that are going to affect vehicle design. You mentioned 5G, there's ADAS, there's autonomy, there's even electrification. And that means automakers are going to be working with some of these entities that are not really in the traditional automotive space, like sensing providers and wireless communication.
Right.
So what sorts of effects is this having on automotive engineering? And in terms of the types of topics we're going to be seeing you guys cover in the keynote.
So, Steve, you want to go first?
Okay, so maybe I can just talk a little bit about so from overall perspective. So traditionally, for automotive engineering vehicle design side, you focus on the vehicle design. So the primary user is the driver, right? And then you have passengers. So going forward in the future, the vehicle being autonomous or semi-autonomously driven, and then you actually have a sort of a machine is driving it. So in terms of who has the ownership of determining how to drive, so the programming does that. So that relies on a lot of on the sensing technology, on the communication technology, and also on the auto driving technology. So that in itself, it's different. And also from engineering side, for auto designer, and to look at the vehicles, you are facing the technology of transition into the electrical vehicles. So the design of EV has also going to be different. So you have to think about in the past, the primary owner is the person. So once the vehicle is being developed on the market, the person takes over. The primary responsibility lies in the drivers. So you have the driver trainings, and you also have the protection system in the cars. But going forward now, it's your technology. So you have to think about a lot of other things. For example, how this auto drive vehicle will be interactive with the vehicle driven by driven by humans or a traditional vehicles fleet, because the autonomous vehicle fleet and the traditional human drive vehicle fleet will be coexisting at least for 10 to 20 years down the road. So during those years, how are these vehicles interactive to each other? And then also, when you drive the autonomous vehicles, or when the autonomous vehicle is driven, how will they interface with the traditional protection system, for example, roadside barrier systems? And what are the speed limit for some of the delivery vehicles? What are the speed limit for the shuttle buses? So these are all the new questions the engineer has to address. And then of course, from engineering side, the sensor technology and also the autonomous drive technology and also the communication technology is a new things for engineering to have to incorporate that. So that goes into that domain, experts of domain of knowledge that need to be incorporated into that. So I'll let Deminda address some of the sensing technologies and how they're going to affect the vehicle designs and how the engineering approach to the solutions.
So let me try to get to the details that Steve was discussing. So there are two things that are most significant. One is a sensing technology that Steve just mentioned, which is for an autonomous vehicle, it needs to work around its environment, which is it needs to know what is in front of it, what's on the side of it. The main reason for that is that in the driving automation, it needs to create a proper trajectory, meaning where will it go in the next control cycle, what is the space, and what's the speed and acceleration and steering angle, so that it could retain its stability but go towards its eventual destination that it's going to end up in. That requires like time to time adjustment of the brakes, acceleration, and the steering wheel every control cycle. And also on the long term, on the medium term, how does it manage the obstacles that it sees in front, or the slowing speeds of the vehicles in front, and look at the side lanes and see if they could actually do a lane change. Sometimes when they do a lane change, they have to abort that, so that way it could not collide or hit other vehicles that are trying to come into that lane or going out of the lane. On the longer term, does this management of lane change, entering and existing into the roads and so on, will it help it get into the eventual objective? So it's a hierarchical planning. I went from bottom up, it's actually from top down. That's one aspect. The second aspect is that these sensors, each individual sensor has its limitations. There are lots of faults in these sensors, and people have launched successful attacks against them. No two of them have the same fault profile. Given the bad weather, the changes of the weather and lighting conditions that could happen during a journey from point A to point B. And that those need to be known by the driving automation, so that when it does not sense an object in front or on the side, it needs to know that it's not because there's no object, because the sensor has its limitations and we've reached the limitation. That's the sensor side.
From the engineering perspective, for the engineers that are designing these vehicles and designing these systems, are they going to need different types of tools for the types of, simulation and testing that needs to be done to ensure that the vehicles are going to work properly and that these systems are going to work properly together? You see new tool sets emerging, or different ways people are using existing types of simulation tools?
Yes, both new tools are emerging as well as existing tools are being enhanced. One of the issues that I did not talk about is safety. There's a lot of work done in enhancing the learning capabilities of the sensors, fusion capabilities of the sensors, and also providing sufficient 5G or beyond bandwidth to share the information as soon as possible. So a lot of the communication toolkits that are coming into the vehicles, and the vehicles will be getting newer and better radio systems, newer and better recognition systems on board, so that it could all be fused and used as one toolkit. The second aspect is that I'm sure Steve will emphasize on this, is the fact that we need to come up with a uniform way to argue about the safety, like quantitatively classify the known and unknown circumstances under which the vehicle can operate, in the sense of what is the probability of misdiagnosis. That has not been done in a standardized way. There are efforts here and there. Some of them are research, some of them are experimental, but there needs to be a framework to be able to argue about the safety or quantify the safety and the conditions under which they will operate.
Yeah, I totally agree. So in terms of the question, Brian, you asked regarding for the capability, I think the software in each respective community has enhanced the capabilities of each individual technology. But I think the most important part going forward will probably, it needs to be integration of traditional engineering, plus the communication, plus the sensing and the 5G, all this are working together. So in the future, imagine right now, when you develop a vehicle, you have a certain federal regulation, which is a testing procedure. So you test the vehicle at a certain speed and certain conditions. And going forward, and these conditions are determined by field statistics, or field statistic meaning the accident data. But going forward, it's not really all man-made accident anymore. It's going to be machine errors and all that. So you can envision in the future it's going to have some kind of virtual testing. So how do we set up a virtual testing? I think right now industry and also the government was, I think, thinking about the framework. So it's and from engineering to design these vehicles, they have to kind of work on a kind of platform to start with. So I think it will be required going forward to develop that kind of safety platform that has integral part of the different aspects of technology all integrated together. And then that, it used to be a very domain specific technology, but I think going forward, you're going to require the understanding the subject of the domain knowledge of several different areas. So that's, I think it's a challenge. It's a challenge also for our university to how to bring up a new student to let them understand all the technologies and then be productive engineering going forward.
All right. Well, that's all the questions I had today for this. Thank you both for talking to me.
Great.
Great. And I'm
thank you.
Looking forward to the keynote. All right. Thank you guys very much.
Thank you. Thank you, Brian. Have a good day. Bye.